The second type of cable construction we want to look at is a so-called distribution cable. There's a number of different names that people use for these, but they're basically a combination of a number of fibers, Kevlar strength members, and a jacket. Now, this cable is too big to strip with a standard wire stripper, so we use what's called a jacket stripper or slitter. This is a heavy-duty tool that we use to take the jacket off. When we cut through the jacket of this cable, we're going to clamp onto it and cut it. But we don't want to cut all the way through the jacket. We only want to cut far enough so that we can break the jacket off. Because if we go through the jacket and into the interior of the cable, we may harm the fibers inside it. So the first thing that we do is we go to the end of the cable and we adjust the depth of our cutting blade. This blade is adjustable. So we adjust the depth of our cutting blade so that we cut about 90% of the way through the jacket. After we do that, go back about 3 to 4 inches on the cable and run the jacket cutter 3 or 4 times around, and then just simply snap the jacket and it should snap right off. When we pull it off, then we'll find Kevlar strength members, and also hiding in here is a ripcord. The ripcord is used to rip long lengths of jacket off the cable. If you're trying to take 3 or 4 feet off, don't keep taking it off in small sections the way we just took the sample off the end. Just simply use the ripcord and rip it back until you get enough cable exposed so that you can do your terminations. The next thing we'll find is a binder tape. The binder tape holds all of the fibers in the cable together. The next thing you'll see is a number of fibers. In this case, there's several bundles. There's approximately 24 fibers in this cable. Let's see if we can spread them out here so you can see them. If we can zoom in on that, you can see there are a large number of fibers. Another binder tape. All the fibers are color-coded, and then there's a central heavy-duty strength member. This strength member is not there for pulling. It's a heavy plastic rod. In big cables it will be fiberglass. It's there to make the cable stiff so that it doesn't bend too far and put stress on the fibers. So the construction of this cable is quite simple. Jacket, ripcord, Kevlar, fibers with binder tape in bundles, and our central strength member. When we're pulling this, the method of pulling it is quite simple. What we'll do is we'll cut off everything but the Kevlar. We'll tie our pulling eye to the Kevlar and we'll pull only on that. So make sure that if you're pulling this kind of a cable, and it's very common to pull it in an interduct or conduit, that you only use the Kevlar to attach your pulling eye for pulling. So this is a very simple cable. It's widely used in building backbones. One of the things about this cable is, though, that it's an indoor cable. It's not designed to go outdoors because there's no water blocking in the cable. There are some new designs now available that are dry water blocked. They actually use a special artificial material in here that absorbs moisture and expands to about 100 times its size. It's actually the same material that's used in disposable diapers. And that will work as a dry water blocking material. So if you go to your cable maker and ask them for a water blocked dry cable, they can make you a distribution cable just like this that does not have gel in it like some of the outside plant cables, but will actually have a dry water block material. So this is a very, very common cable for use in buildings. On any given cable, there's a lot of information printed on the cable itself. For example, there's always the manufacturer's name, in this case Northern Lights Cable Incorporated, and their part number. Every manufacturer will put that on the cable to make sure that you know where the cable came from, so it's traceable. Then, here it says OFNR UL riser cable. OFNR UL riser cable means that this cable is rated for flame retardants. You never install a cable indoors unless it has a UL flame retardant label on it and a code. This code OFNR means optical fiber cable, N for non-conductive, R for riser rated. That means it's rated for its flame retardant when the cable is held vertically. The UL approval is very important. Never, I'll say this several times, never ever install a cable in a building that does not have a UL flame retardant label on it, because that means the cable is not rated for indoor applications. Indoor cables are typically, for riser, they're flame retardant polyvinyl chloride. When you have a cable that's outdoor rated, the jacket is polyethylene and it's not flame retardant. So make sure that you always look for the UL flame retardant label on any cable you're installing indoors. If you install a cable that's not UL rated and an inspector sees it, he'll make you take it right out. Next piece of information, in this cable it says 62.5 125. That's actually the type of fiber that's in this cable. It's 62.5 micron fiber, multi-mode fiber. And then, in this case, it says 001927 feet. That's a distance marker. Cable usually is marked in either feet or meters, every 2 feet or 3 feet or 1 meter. And that is the way that you know how long the cable is that you just installed. If you're pulling a cable and you want to know how long it is, you can use the distance markers to find out. If you know how far you're pulling the cable into a conduit or an interduct, and you know the length of cable from the measurements on the spool of cable you've got, then you can tell whether or not you have an adequate amount of cable on the spool in order to use for the length that you have to pull. And one more thing, I'll say it one more time. Never install a cable that does not have a UL rating for flame retardants. Okay? So there's a lot of information on the cable. It's good to read it. Make sure that you get what you expect, and use the distance markers to see what you've got for length. With our distribution cable, when we terminate it, we can actually terminate on the 900 micron buffered fibers themselves. To terminate this, what we'll do is we will cut off the Kevlar with our Kevlar scissors, and we'll cut off the center strength member, although we may leave a couple of inches so that we can tie it into, clamp it into a box. Now, each of these fibers can be terminated directly. We can put a connector directly on the end of that fiber. However, because there's no cabling around it, there's no protection for that fiber, we do not want to have it out in the open. So with a cable like this, we'll terminate each of the fibers separately, and then we'll have the cable inside a box or tray to protect it. So we'll bring this into a room, a telecom closet, a computer room, and we'll have a box on the wall where we actually have the cable terminated inside the box to protect the fibers. But there are times that that is not very easily done. Suppose we're merely running a small number of fibers from one point to another, connecting up some industrial equipment, or a hub to a hub on another floor. There is an easier type of cable to use, and that's what we call a breakout cable. Let's take a look at a breakout cable.